Hello! Today we're going to be building this 7-inch long-range FPV drone for under $150. Let's get started. The main reason why we can do this build in 2024 is because of this, the motors. You can get a full set of 4 for under $35 shipped to your door. Thanks to the conflict that's been going on overseas, bigger drones, bigger motors are being mass-produced more in China. So in the past, if you wanted to build a 7-inch long-range drone, you had to go to a name brand manufacturer to buy these 2807 motors, and they generally charge upwards of $30 for each motor. And that's just crazy, even though it barely uses any more material than a 5-inch drone motor. It was basically just because not many people were building 7-inch drones, they weren't selling as many motors, so they were hiking up the prices. But now with the conflict, there's a huge demand for larger and larger drones to carry bigger payloads, and so now they're mass producing these big motors for cheap. And as a teaser for a future build, it doesn't stop there. Check out this motor here. This is a 3115 motor. This is absolutely huge. Just look at the size comparison between these. It is massive. This will spin a 10-inch prop, and you can get a full set of these 10-inch drone motors for under $50. Yeah, that is absolutely nuts. So stay tuned. I think I'm going to be making a under $200 10-inch drone build video in the future. So if you want to keep an eye out, please like and subscribe, and I'll be posting that video soon. Alright, so let's take a look at the other parts we're going to use in the build. The first is going to be the frame. The frame we're using is the Mark IV 7-inch version. This is the clone version, and this costs just $15 on AliExpress. That's pretty nuts. And you can see I've already done a dry assembly of it right now. I always recommend when doing a drone build to do a dry fit like this with no electronic parts, no soldering. Just put the frame together, bolt it together, just so you know how exactly everything's going to go, and you can plan things out a little better that way. Also, make sure that when you buy it, you buy the version of the frame that comes with these 3D printed accessories, so you can mount your GoPro and have some extra protection for your motors and stuff. I'll put 3D printed in quotes because they're making so many of these that they're actually made out of injection molded plastic, which is actually kind of cool. For the flight controller and ESC stack, I'm going for this kind of generic F4 V3S stack that comes with a 45 amp ESC. You can also get this in a 60 amp ESC. I made a previous video on these flight controller stacks, so you can check out that video as well on how to get the best deal on these. They'll come under a couple different brand names. There's like this one which I have, which is Yasido, and there's also one by like 99mod, but they basically come out of the same factory with all the same schematics, so they're just going to be all identical. And the amazing thing is you can get these stacks for under $40, which is absolutely crazy. It's even cheaper than, you know, the Speedy Bees, which generally cost about $60. For the receiver protocol, we're going with Express LRS, and I'm using the Happy Model EP1 micro receiver over here. And one little word of caution I have for this is that for some reason, they don't have the wires included in the bag. So you get the receiver, you get 2 separate antennas for different lengths, which is great, but you don't actually get little silicone wires to actually wire it up to your flight controller. So if you do need the wires yourself, you might want to choose a different receiver. I recommend something like the JHEMCU Micro Express LRS receiver that comes with the wires, and it's a little bit bigger. For our FPV video system, we're going for analog because that's going to be the budget option. So I'm going to be using the Rush Tank Solo VTX, which goes over 1 watt of transmit power, but it costs under $35. It's also really well built. The case is all aluminum. Now, as far as the antenna goes, the little whip antenna that comes with these aren't that great, so I'm going for a Rush RHCP SMA antenna, so I got one of those as well. You can also get these for really cheap on AliExpress. These are like $5, and links to all these will all be in the description below. For the analog camera, we're going for the Runcam Phoenix 2 SE. The main reason I'm choosing this is because it works pretty well, and it's available for really cheap, under $15 on AliExpress. That's an amazing deal. All right, and with that, we got all the parts ready to go. Let's go ahead and start the build. The plan for this build is to dry fit as many components onto the drone frame as possible before we start cutting wires or touching a soldering iron. So once again, the idea is to make sure we get everything right the first time and not have to undo anything in the future. But the first thing we should do is take our flight controller and plug it into our computer running Betaflight Configurator to make sure our flight controller is working properly. We want to make sure that everything is A-OK and the firmware is updated before we put any solder to the flight controller, just so that if there is something wrong with it, you can return it and you know it's not your soldering that messed up the flight controller. All right, I have Betaflight Configurator open on my computer, so let's plug in the flight controller and hope it recognizes. All right, looks like it recognized. We can apply custom defaults, and we get some warning about the accelerometer. That's fine for now. And we have it connected, and let me jiggle the flight controller a little bit, and it looks like it is moving properly. So yes, we know the flight controller is operational, it is functional, which is great, but we will see at the top left here, we are on firmware 4.4.2, which is actually a little bit old at this point, about a year old, I think. So the flight controller is working great, but we want to upgrade it to the latest firmware. So let's go ahead and do that right now. We're going to start by hitting the upgrade firmware option at the top right, and we're going to hit auto detect here to detect which board we actually have. We get the Omnibus F4SD. Now, if you bought the same exact flight controller that I linked in the description below, it should be the same exact one, Omnibus F4SD, and it's pretty important to remember which one because there are lots of different versions of the Omnibus F4. If you do buy a different flight controller, just go by whatever the auto detect detects as your flight controller. So for me, F4SD, that's great. And then we're actually going to be tempted to load the firmware right now and then flash it, but we're actually going to get an error because we're not in the programming mode. So to put it into programming mode, you can either hold the boot button on the flight controller, but a different way I find to be a little bit more reliable is actually to go back into the Betaflight configurator, connect to it, and then go over here and actually hit the Activate Bootloader DFU button. We can see now that it disconnected and reconnected under DFU, and we can once again go into the Update Firmware, and we can manually search for the board. We can't auto-connect at this point, but we can manually search for the Omnibus F4SD. And we should be all set to go. We have DFU up here, we have Omnibus F4SD set here, and we can select the latest version, which for me right now is going to be 4.5.1. Before we were on the 4.4.2, which is like a year old, so there's been a lot of updates since then. So yeah, we're going to choose the latest, 4.5.1. We can once again load the firmware online. There's a bunch of settings over here, but the default is generally going to be fine. So we've loaded the firmware, and now we can flash the firmware. Now, this firmware flashing is going to take a minute or so. If you haven't gotten to this point as of yet, there are lots of resources online. You know, Joshua Bardwell has tons of videos on how to upgrade the firmware on your flight controller, so check that out if you're having some issues connecting and upgrading the firmware. All right, it says programming successful, so let's connect to it again. And actually, let's just go ahead and calibrate the accelerometer while we're here, and jiggle the flight controller around, and we can see it's still working properly, and we are now on the latest firmware version 4.5.1. So that's great. We're done here. We can unplug this and go back to our dry fit of the build. All right, now that the flight controller is confirmed working, it's time to mount this and the speed controller into the drone. To mount it, we have to put the little rubber gummies onto the mounting points of the flight controller. The easiest way I've found to do this is to use tweezers and just squeeze them through, pinch the little rubber thing, and then you can squeeze them through the holes. Now it's time to loosely mount the stack into the frame using some M3 bolts. Note that for this particular frame and stack, the mounting bolts weren't included in either of them, so I had to bring my own M3 bolts. If you don't already have one of those M3 bolt assortment kits, I highly recommend you pick one of those up because you're always going to need M3 bolts in the FPV world, and they're going to come in handy real soon, as you'll see with the motor mounting. All right, so the next step of our dry fit test is to figure out how long to make the motor wires. So we're going to mount just one motor to the frame and draw them out to the flight controller to figure out the motor lengths. But there's an issue, and that's that the bolts that came with the motor are way too short for this frame. They don't actually reach the motor when you screw them in from the bottom. And so this is why we do the dry fit, to figure out what little issues we need to fix and solve right away. And so what I'm going to do is I'm going to take some 8 and 10 millimeter long bolts from my M3 bolt assortment kit and use those to mount the motor instead of the stock screws that came with the motors. Next, it's time to dry fit our video transmitter and the camera into the frame. Thankfully, our Rush Tank video transmitter has 20 by 20 mounting holes built into it, so all we need to do is take M2 screws and mount it directly into the back of the frame. And next, from the frame accessory kit, I'm going to grab the little antenna mount and mount in the antenna adapter. The Phoenix 2 camera is going to go up front, and once again it mounts with M2 screws. Alright, now it's time to finally bust out the soldering iron to solder the battery leads to the 4-in-1 ESC. And now, unfortunately, this very first soldering job is also the most difficult soldering job because the ground plane on the ESC will sink a lot of heat. So this can be a little bit tricky if you're new to soldering. Now, in order to do the right job, I recommend using the right tools first. And so you have to get a really good soldering iron. The iron I'm using is called the Pine Sill. There's also one other iron I recommend, which is the TS100. These irons are pretty cheap. You can get them for about $30. They have little microprocessors to properly ramp up the heat as needed. And the real key thing that makes these irons really amazing is that the little temperature sensor for the iron is built into every single tip. So that means every soldering tip is a little bit more expensive to make, but it reacts really fast to changes in heat. So when I'm sticking this soldering iron tip to the huge plane of the 4-in-1 ESC, the temperature drops really fast, but the iron can quickly read that temperature drop, and then it'll put more power into the tip in order to maintain the solder melting temperature. And so as you can see here, I pretty effortlessly soldered the little red wire onto the 4-in-1 ESC. If you don't have a smart soldering iron like this, if you have a cheap pencil iron, or even an expensive, nice soldering station, the issue is that they react so slowly to the huge temperature drop when you put your iron on a large pad that sometimes it won't melt the solder. And in the old days, what you have to do is you'd have to crank up the temperature and then work really fast to try and melt the solder, get all the heat into the solder pad before it overheats everything else. That's a little bit of a tricky skill to do, and if you just want to avoid that, just get a TS100, get a Pine Sill, and these newer generation of irons just make it so much easier to solder these leads. Next, it's time to test the system out for shorts using a smoke stopper. So the smoke stopper will prevent too much current from going into the speed controller in case there is a short. So what I do is I plug everything together. I plug the smoke stopper into the ESC, I plug the ESC into the flight controller, and then you plug a battery in and just make sure there's no beeps coming out of the smoke stopper, make sure everything's okay. And this is also the perfect time to upgrade your ESC's firmware. So we've already upgraded the flight controller firmware. Now, if you want to upgrade the ESC to, say, run BlueJay, which is an upgraded firmware, you can do this right now since everything is all powered up and easy to access. And it looks like everything is good to go, so let's continue on with the build. Alright, next it's time to solder the motor wires to the ESC. Now I'm actually going to do something a little bit different, and I'm actually using connectors in between the motor and the ESC. Now this isn't very popular, but I'm doing this because I'm planning on making lots of videos and doing lots of different builds with many different combinations of motors and ESCs, so it's going to be really convenient for me to just have connectors that I can pop on and off real easily. These are called MT30 connectors. Once again, you don't have to do this, it's completely optional. You're totally fine just soldering the wires directly to the ESC. And here I am soldering the connectors onto my wires. If you don't already have a pair of magnetic third hand tools, I really recommend them. These help so much in holding all the parts together and stuff we need to solder things together. So go ahead and solder your motors to the ESC. Alright, at this point the drone should be looking like this, with all 4 motors wired up to the speed controller. Next, it's time to wire up our accessories, like our Rush Tank VTX. So from the Rush Tank to our flight controller, we just need to wire up 4 of the wires. We need ground, we need power, we need the video signal, and then we need 1 UART in order to control the video transmitter. Now, I'm going to put the wiring diagram of this exact build into the description below. This wiring diagram is one I'm making exactly for this build, so you can follow along exactly as I'm doing. Now, compared to the ESC, the flight controller has tiny pads, so we want to switch over to a smaller soldering tip size in order to solder these things really well without any shorts. Next, it's time to wire up the camera to the flight controller. This only has 3 connections, which is ground, 5 volts, and video. Alright, the final thing to mount is our Express LRS receiver. I'm using the shortest antenna, and I'm putting it into the 3D printed mount, and the receiver is just going to live right on top of the VTX. Now, to wire it up to our flight controller, we have 4 wires. We have ground, 5 volts, and then the 2 UART wires, so it's time to wire that up. And once again, the wiring diagram is going to be in the description below. Alright, and with that, all the wiring is done. So it's time to plug it in. Let's get the receiver binded to our radio. And if you don't already have a controller, I really recommend the Radio Master Pocket Express LRS version. It's $60, and this thing is built like a tank. I actually use this more than I use my bigger $200 TX16 because this little pocket, it just feels durable. I can just throw it around and I just don't give it a care in the world. I really recommend this. To bind your Express LRS receiver to your transmitter is unfortunately the worst part about Express LRS. There are a whole lot of different methods to do it, and if it goes well, that's fine, but if it doesn't go well, it's really frustrating. It is like the number one question in the FPV community, the number one issue: how do I get these things to bind? Thankfully, people like Joshua Bardwell have tons of videos on Express LRS binding, so I'm going to direct you over to there if you have any issues. For me personally, I like using the binding phrase method. And to get my binding phrase into my receiver, I like to use the Wi-Fi configurator by leaving the receiver plugged in for 1 minute and then connecting to the receiver via my computer's Wi-Fi. Alright, now that our receiver is bound to the transmitter, it's time to button the drone up back together. So we're going to physically put it all back together except for the props, because the next step of the build is to connect it to Betaflight Configurator and do our final configuration. Doing the final setup in Betaflight Configurator is going to take a really long time, so I'm going to save that for the end of this video for those of you who actually have the drone in front of you right now. So in the meantime, let's pretend it's all set up, and let's take this drone out for its first flight. Alright, it's a nice day at the pond. Let's take out the 7-inch with the GoPro. Alright, so here's my GoPro footage from my GoPro Hero 8, and at the bottom right I have overlaid the DVR footage from my analog goggles, so the bottom right is what I'm actually seeing while I am flying. This flight is going to be nothing too special. I'm just going to be doing just a little cruise around the pond. I'm not going to be doing any freestyle or any long range. This is one of my first flights, so I'm still seeing, testing at the limits of the drones, making sure there's no quirks or anything wrong with it before I push it too far. Now, if you look at some of the OSD elements on the bottom right, you're going to see that some of them look a little bit wrong, especially like the current draw. It shows that I'm drawing less than 1 amp of current this entire flight, and that's wrong, and unfortunately that's because the current sensor on my flight controller is broken. It doesn't work. I've tried calibrating it and it still shows, really crazy values, so I think I'm pretty sure the current sensor is broken. The voltage values are still correct. And that's kind of like the downsides of buying a budget flight stack like this. There isn't a lot of quality control, so I think the current sensor came broken from the factory and nobody caught it. It's not the biggest a deal, so I'm just going to keep on flying like that. Overall though, the 7-inch just flies really great. It flies really in kind of like a more relaxed style, perfect for cruising, and hopefully one day I'm going to be doing some really long range flights with this. Compared to a 5-inch freestyle drone, this thing is a lot more floatier. 5-inch freestyle drones are kind of like hot rods. They have a lot of power packed into a really small space, a lot smaller, like disc loading, those tiny 5-inch props. Whereas a 7-inch, it doesn't weigh that much more than a 5-inch, but the 7-inch just has those huge props, and it means there's it's less disc loading. There's less weight compared to how much prop area that has. So it's kind of like similar to RC planes. A warbird is going to have, a lot of power compared to a small wingspan versus like a trainer that has a much larger wingspan for the same amount of power. So it feels floatier, it feels more relaxed to fly. And that's kind of the same deal with the 7-inch versus the 5-inch. The battery I'm using for the 7-inch right now is a 4S. I think it's a 1800 milliamp pack, but there's a lot of wiggle room to use different amount of packs. I've actually used a 4S 2P 3000, 5000 milliamp hour Lion Pack 2, and I've actually gotten over 20 minutes of hovering time on this 7-inch drone. It's pretty crazy. Even just on this current pack that I'm flying with right now at the 4S 1800, I think I can get over 7 minutes, close to 7 minutes of flight, and that's a lot more than a standard 5-inch. That's just because you get a lot better flight efficiency when you move to bigger props, and so that also what lends this to being a much better long-range drone. The one thing that is kind of missing from this drone at the moment is a GPS module for long-range flights, because I want the confidence that, if I'm going to be flying like a mile away from me, that if I do lose signal or something, that the Betaflight, return to home feature and stuff, that's going to work properly. So that's going to be my next step in a future video, adding a GPS module to this and setting up GPS rescue and stuff, and that way I can actually do really long range flights with the comfort of knowing the drone is probably going to be safe. But anyways, that's it for this video. I hope you found this video helpful in building your own 7-inch drone for under $150. If you did find this video helpful, I'd really appreciate it if you could subscribe to my YouTube channel. That'll help a lot. And of course, if you have any questions, please leave a comment and I'll try to do my best to answer them. Also, links to all the parts I used will be in the description below. And as I mentioned earlier, if you want to stick around for the beta flight setup, then that's going to be coming up next. Thanks for watching. Alright, it's time for the beta flight configuration of the drone, and before we even plug it in, we need to do a couple of steps to prepare ourselves. The number one thing to do, it's really important, is to ensure that the props are off the drone. Next, because we are going to be plugging in the drone and leaving it plugged in for a while, we want to make sure that things like the video transmitter and the flight controller are actively cooled, because they won't, we're not flying it right now, so we want enough airflow to go over them to make sure they don't overheat. So I have a USB fan plugged in and pointed at the drone at all times to help cool it. And one more thing we have to do is we have to make sure our transmitter is on and powered up, because we will be testing out the receiver as well. So number 3, my transmitter is powered on and we're ready to go. So next, we're going to take a battery, and I'm going to be plugging it into the drone. Note that I'm not plugging in the USB just yet. We're going to start with the battery. The order of operations does matter a bit, because we want the flight controller and speed controller to be talking to each other successfully, and generally you need to plug in the flight battery first. So alright, flight battery is plugged in, and right now my video transmitter is on as well, and I'm going to be manually clicking the button in order to move it into the lowest power state. This is because I don't want it to heat up too much and overheat. Alright, so I've clicked the power button on the Rush tank transmitter until the LED turns green, which is its lowest power output, which is 25 milliwatts, so it shouldn't get too hot. And now it's finally time to plug it in. This little V3S flight controller uses a micro USB cable, so let me get one of those. Alright, we are plugged in. Now, the first thing I always like to do is to make sure that the receiver is set up properly. So we're going to go over into ports, and we're going to set up our serial RX. So the way we soldered it up is it should be on UART1 is going to be our ELRS receiver. So we'll do that, and we're going to just hit save and reboot. Alright, and now we're going to go over to the receiver tab, and now we're going to see if we have a proper response, and we do. So roll, pitch, yaw, and throttle, so everything looks good there. And over here at the top right, serial via UART, that's the default, that's fine. And serial receiver provider, CRSF, that's Crossfire. Express LRS uses the Crossfire protocol, so that's right. Telemetry, we do want telemetry. So everything looks okay there, so easy as that. The receiver is all set up. Next, I want to check the actual orientation of the flight controller. So basically, you want to carefully pick up your drone and you want to move it around. So I'll tilt it back, and the little picture of the drone tilts back. I don't tilt it forward. The picture of the drone tilts forward. I want to tilt it to the left, tilt it to the right, and spin it left and right. So the flight controller orientation is correct in that case, because the movements I'm making to the drone are matching what's shown on the little simulation there. Now, if this is wrong for you for some reason, sometimes this can happen. It could be not your fault, it could be your fault. Sometimes the configuration out of the box is wrong, but you can go over here to board and sensor alignment, and that's where you can adjust the virtual alignment of the flight controller so you can match the actual movement of the drone. Alright, let's see if there's any other settings in the configuration that we need to do. I think all of this is pretty much just fine. There's some other things like LED strip. We don't need the LED strip. And maximum arm angle. This is a little bit of a weird feature, but basically this will prevent it from arming if it's too far out of level. But the issue is if you accidentally disarm midair and it starts spinning, you won't be able to actually rearm it. So I always like to set that to 180. I believe that disables it. So yeah, 180 will disable the check, so we can arm or disarm it no matter what orientation the craft is in. Okay, and we'll do that. And craft name, I like to label my drone, so we'll do 7-inch. And hopefully that'll pop up on the OSD later. So we'll do save and reboot. All right. Next, let's take a look at the motors, and let's make sure that the motor order and motor direction is correct. Now, this is once again the crucial part where you want the props off, because we will be spinning up the motors. So let's go ahead and first check to make sure that all 4 of the motors are spinning. So I'm going to do I understand the risks. Also, for whatever reason, if you have a smoke stopper plugged in, this is where you probably want to not be using a smoke stopper, because we will be powering up the motors. It will be drawing a lot of current, and so you don't want the smoke stopper. And this is also where you want to double check your battery to make sure that you're not draining your battery too much. Make sure you have a decent enough charged battery. I plugged in a 3S. This drone can fly on 3 or 4S, and I have a 3S plugged in, and it's actually kind of a little bit on the about halfway charged. It's not the worst, it's not the best, but I'll just keep an eye on this voltage here to make sure it doesn't drop too low. And I'm going to very carefully draw the master slider up to make sure to see all 4 motors are spinning. And they are. All 4 motors are spinning. That's all you need, at least for my drone. You just need to flick it up just a little bit, and I could see all 4 motors spinning. So that's good to make sure that, just a sanity check to make sure my soldering connections are all good. So that's fine there. But then we need to check the motor order and also the motor direction. So the motor order, the quad needs to know like which motor output goes to like which physical location on the quad. And so we're going to go ahead here. We're going to do stop motors, and we're going to do the reorder motors wizard. So once again, props are off. I understand the risks. Start. And so now it's spinning the motor. Right now the bottom right is spinning, so I'm going to click that. Right now the top right is spinning. I'm going to click that. The bottom left is spinning. I'll click that. And the top left is spinning, and I'll click that. And we're good to go. So we're going to do save. Okay, and we're going to go back to the motors tab, and we're going to do a little sanity check. Again, make sure the settings have properly saved up. So once again, I'm going to do I understand the risks, and this time I'm going to be spinning up each motor manually. So 1 is going to be the bottom right motor, so I'll spin that manually. That's great. 2 is going to be top right. Great. 3 is bottom left. Great. And 4 is top left. Great. All right, so the motor order is correct. We've gone ahead and gone through that wizard, but now we have to do the motor direction wizard. Brushless motors have a specific direction. Usually when you solder, you just solder whichever wire is closest, and then you'll use this motor direction wizard to change the direction of it manually. And you can see the arrows here are pointing to which way they should be spinning. So in general, the props are always going to be spinning towards this center line. So here we see props are spinning up and towards, and down here it's going to be down and towards. So we're going to hit motor direction. Once again, the props are off, and we're going to just go through the entire wizard to do that. So we're going to start, and the motors are going to start spinning. It can be kind of hard to tell which direction each motor is spinning, but what I like to do is I like to lightly, very carefully put my finger on the bell to kind of slow it down a little bit, just a bit, and you can kind of tell by which way your finger moves, which way the motor is spinning. So I'm lightly putting my finger on motor number 1, the bottom right one, and it's spinning the wrong way. So right now, the correct direction it should be spinning is this way, clockwise. But by putting my finger on it, it's actually spinning counterclockwise. So I'm going to click the 1 button, and that's going to spin it the other direction, which is now correct. So it's changed the motor spin direction. That's correct. That's great. Let's go for motor 2. That's also spinning the wrong direction. So I'm going to be clicking that, and now it's correct. Cool. Motor number 3 is correct for me, and motor number 4 is also incorrect. So we have a bunch of these motors spinning the wrong way. This being right or wrong isn't like a mistake in soldering. This is all purely done in software. There's no downside of this being right or wrong. It's just you just click to make sure all the motors are spinning the right way, and you're going to be good to go. And there we go. And that's all we need to do. There's no save button. We're just going to do close, and it'll be saved. And once again, if you do want, you could do another little sanity check where you just spin each motor individually, and the settings should save. So let's spin the bottom right motor. We did reverse this motor just earlier, and it is spinning the right way. So that's a quick little sanity check. All the motors should be good, and we should be good to go. All right, so our motors are set up, our receiver are set up. One other important thing to do is set up our modes, our flight modes. So first of all, let's just make sure that there's no mode set up right now. So all the modes are blank. That's good. Let's go over to our receiver, and there's no correct way to set up your modes. It depends on how your transmitter is set up. The two important modes are the arming and then the angle mode switch. So for arming, for Express RLS, you always want to use aux1, and so you want that to be armed, you want 2000 to be armed, and you want 1000 to be disarmed. That's just baked into Express LRS, so you kind of have to do it that way. And then for my mode switch, I think I have it set as aux2. Yeah, so personal preference, I like 1000 and 1500 to be acro mode, and then I have 2000 to be set to stable mode. So I gotta keep that in mind. aux1 is the arming, and so 2000 is armed, 1000 is disarmed. So let's go into modes. We're gonna be doing add range. We have aux1 for arm, and we want arm to be 2000, so we'll slide it over there. And then for the flight modes, all we need is the angle mode. That's aux2, and we want that to be 2000 and 1500, so we'll slide that over there. So we have acro mode there, and then these other switches will be angle mode. Let's just double check. And then for arm, we want right now it's armed, and everything else here will be disarmed. Cool. So that's all we need. All right. And oops, right now I have my arm switch set, so I'm actually gonna, just for safety reasons, I'm gonna disarm it. Okay. So the last thing we need to do is we have to do the OSD and video transmitter, and this is where things get a little bit complicated. So for our OSD setup, this is a little bit finicky. The first thing we want to make sure is to make sure our video transmitter is recognized, and right now our VTX isn't configured. That's right. So we have to go back into ports, and we have our VTX set up to UART3. UART3 is what we connected our Rush Tank VTX to earlier, and our Rush Tank is, I believe it's a smart audio protocol. It's going to be either IRC Tramp or smart audio. Those are the two protocols that analog receivers use, and I believe it is smart audio. So we're going to do save and reboot, and hopefully it's going to recognize it. So we can go back over to video transmitter, and it says device ready true, and we have it recognized as smart audio 2.1. Okay. I do have a little analog VTX monitor with me right now that I use for bench testing, and it does show a video signal, so that's good, but there's no OSD elements at all. The first thing we want to do is we want to enter in a VTX table. This VTX table is going to tell Betaflight and whatever which channels, which power levels this VTX has. So let me try and find the VTX table for the Rush Tank Solo. All right, I've gone to the Rush website, and I've gone ahead and I found the VTX table for the Rush Tank Solo. Here it is, Solo Smart Audio 2.1, and we have the 48 channel version. So I'm going to download this JSON file, and then I'm going to go ahead and I'm going to load from file that JSON file. All right, it's loaded our VTX table here, so hopefully this is going to be correct. Let's go ahead and actually enter in my default band and channel. I like to use band A channel 6, and the default power we're going to set to 25. We're not going to use low power disarm for now. We're going to hit save. Okay, and next I want to just double check to make sure these power levels are going to be working properly. So the Rush Tank VTX has the colored LED to tell what power level it's on. So right now I have it set to 25, and that's green as before, so maybe that's working, maybe that's correct. This is the biggest issue with these VTX tables, is that these power values, that's really what the VTX needs. It might be right or wrong depending on how old or how new your VTX is, or how old or updated the manual is. This is definitely the place where you're going to have the most troubles. These bands and channels up here are all pretty universal, so you don't need to mess around with that. Those are always pretty much the same. It's just these power values that can differ depending on the VTX. So let's see if it's correct. So let's go ahead and go to the 400 power level, and I'm going to hit save. And so let's see what the LED turns to. It turned yellow, so that's good. So that, I think that's correct. So for 25 it was green. Right now it's yellow for 400. Let's go back to 25 just to make sure it turns back to green, to make sure the green level is working. Hit save. Yep, it turns back to green. That's correct. Let's go to 800. What color will that be? Red. Okay, so it goes green, yellow, red for 800, and then max I think is going to be purple. Let's do that, and it does turn purple. Okay, so this VTX table is correct. That's great. And we're not going to leave it on max for too long, so we're going to hit 25, and we're going to go back to save. Because we're on the bench, we're going to keep it on 25. And now this is where we can kind of decide which power level we want during flight. I don't want to accidentally fly on 25. I think because I'm going to be sticking relatively close to me, I think I could stick it on 400 and be relatively safe. So what I'm going to do is I'm going to stick my power level to be 400 milliwatts, but then I'm going to do low power disarm equals on. So what that means is when you first plug it in, it's going to default to 25, but then once you arm, it's going to send the command to the VTX to be 400. So now if I hit save, it's still going to, the LED is still going to be green because I'm not armed. But if I do arm the quad, if I was going to be going flying, it's going to be turn it to 400, which would be yellow. So yep, it's still green. And so everything on this page, this video transmitter page, should be good to go. And now all we have to do is set up the OSD. So let's go ahead over to the OSD tab. First of all, it says HD mode. I think it remembers I last set up a DJI drone, and I think Betaflight for some reason remembers that, which is annoying. So we're going to go back to the NTSC, which is going to be the analog setup. And let's go over here. It says low voltage, so it looks like we have a warning setup. We have warning set up. Let's move the warnings over to the middle. And now the OSD setup is going to be purely like your personal preference. There is going to be a couple really important things. The main one is going to be, first of all, the timers. We want the on time and the flight time. Here we go. So let's set that up over here. On time, flight time, and then we want cell voltage as well. Let's see, where is battery voltage? Battery average, cell voltage, that's a really crucial one. Now I'm looking at my portable monitor on my desk right now, so I'm seeing the live output from the video transmitter, and nothing is coming up so far. Let's hit save and let's see if it shows up. Nothing shows up again. I think this is because we might have to reboot the flight controller. So that's what I'm going to do next, because I want to configure this OSD. I want to see live on my monitor what the OSD elements look like. So I'm going to, we saved, everything is saved for now. So I'm going to be unplugging the USB first. So my USB is unplugged. Next, I'm going to take out the battery. So now my quad is completely unpowered. Now I'm going to plug the battery back in. And then I'm going to plug in the USB back in. There we go. We're connected. And and looking at my monitor on my desk, I do have the OSD elements. Yeah. So that's what I suspected. In general, you never have to reboot your quad to do any of these settings except for the OSD setup. So when you're setting up the OSD, you do have to save and reboot your quad. But now I do see my warnings and these little voltages coming up. Before I start arranging these things nicely, there's a couple other things I want to do. I like the artificial horizon a lot, so let's enable those two, and those things are just going all over the place. This is the reason why I'm moving the Betaflight setup to the very end of the video, because it's kind of boring and slightly annoying to get all of these things to align properly exactly. Also, these artificial horizons, they're never exactly perfectly centered. That's pretty close. We'll do that. I'm going to do the voltage or warnings in the middle, and then we're going to do cell voltage right here. Looks like we have a little more space on my monitor, so we'll do cell voltage down there. We'll do flight times down here. I can't go too far to the right, so we do that. We're going to set our VTX. I want to see what my VTX band and channel is. We're going to enable that here. We'll put that at the top left. I can't see that, so I'm going to move it down one. There we go. We can add some other little fun details, like, let's see, throttle position. We can put that at the top right. I can't see that right now. We'll do that. Okay. What other things can we add? Once again, it's all personal preference. Craft name. Oh yeah, let's do that. This is important because when I'm recording the DVR footage, I can sometimes forget which drone I'm flying when I'm looking. Sometimes I'll record footage and then like 3 months later, I'll actually download the footage and I'll have no idea of which quad was actually flying. So we'll do that. And I think that's good. If the current sensor was working, this is where I would do the actual, what's it called, battery current draw over here. So I'll show my little amp draw. But as of right now, as of recording this, I do know that the current sensor is broken, so I'm not going to be putting my current draw there. But that's also that also can be something that's useful to add. Anyways, that's fine for a basic rudimentary OST. So I'm going to save that. And the drone is ready to go. I believe that's everything for the beta flight setup that needs to be done. And there you go. Hopefully, if you're following along, hopefully you're also successful in setting up your drone. There you go. And thanks for watching. Don't forget to hit save.